data visualization, and everything that is related to oil and gas data analytics. So the screen should be visible and my voice should be audible. If yes, please say so in the chat box so we can go ahead and start the session. Okay, so I will be starting the session with something that might be interesting to some and it might not be interesting to others. Not everything in Power BI is possible, especially whenever it comes to visualization, because sometimes people have very specific visualization need, and Microsoft, the creator of this software, actually they knew this from the beginning. So they added a support for programming languages that you can use in order to integrate with Power BI seamlessly. The two programming languages that are actually supported by Power BI is R programming language and Python. So let me show you why would you need a integration with a programming language. And I promise you it's easy. It's not that hard. Okay, so sometimes whenever you're working with complex data or complex requirements for data, you would need some form of data manipulations that are extremely advanced. So I will just give you an example. If you're working with daily data coming from OZPI server, which is a live data streaming server that is usually linked to oil and gas assets, wells, pipelines, separators, you name it. And usually those types of data, they actually go through some form of filtering in the server. They where the data sits. However, not all the filters are applied equally. And sometimes we have some form of data where outliers, they do exist in the data. For example, minutely or hourly production data, sometimes they have outliers in it. Now, in order to actually to build a data cleaning method or data manipulation method that will actually detect those outliers, there is no software in the market actually now can do this, paid version or even free versions. Now, how do you do this? Usually you integrate Python in the mix. You will add a specific Python script that you actually test somewhere else before you integrate with Power BI. And that Python script will actually detect the outliers for you. Once the outliers are detected, you can just go ahead and include it or just remove it altogether from the module. So this is the first use case of having Python integration, or let's say programming language integration with Power BI. Plus the ability to create custom visualization. This is something that I will show you now. And of course, you can go ahead and integrate machine learning and AI. And let me tell you, incorporating machine learning and artificial intelligence solutions in these types of software, they are usually expensive if you try to purchase this service, and they usually charge on monthly basis as a service. But you can go ahead and integrate machine learning and artificial intelligence as a free feature. Or the only thing you need to know is just a few lines of Python code. Plus, you can do statistical analysis. You can do time series smoothing. For example, we have different algorithms for time series smoothing. This is extremely useful whenever we're working with the production rates per phase-wise, wellhead pressures and wellhead temperatures, where there is smoothing required for real-time data that we're capturing. Okay, so what are the libraries that are usually supported by this type of integration? If you're not familiar with Python, that's okay. I will just try to explain each and every library as I go through them. So the first and the most important library that is supported in Power BI is Pandas. Pandas basically is Python's answer to Excel. You can use Pandas as a library to manipulate or let's say work with tabular data. You can do virtually anything with this library as long as it's related to to tabular data. One of the very interesting uses of pandas is actually to read up LAS files or well log files, and you can serve them as a Power BI table. Plus, you can use Matplotlib, which is one of the strongest library that you can get where you can generate plotting. This is something that I will be using now. You can, of course, also use Seaborn. Seaborn is very effective, especially when you are trying to create pair plots. You can use NumPy. NumPy is very good at mathematical calculation and array calculations. You can use sklearn, or it's known as scikit-learn. This is very useful whenever you're working with machine learning. Different types of machine learning works very well. For example, you can use it for classification problems. You can use it for regression problems. And all of these is just inside Python and Power BI integration. You can use Plotly, however, it's very limited. So let's just discard that. And of course, you can use another library. It's called Stats Model. Stats Model actually provides some more algorithms regarding statistical analysis and the machine learning. Okay, so let me just go ahead to one of the data sets that we provide in the training. Basically, in this training, we provide 5 actual data sets. Okay, so let me just do one thing for you. I will go to the table view, or let's go to the data view. If I open up one of the header files that actually contains all the information about the wells, you can see we have many columns. And of course, not all of the columns are populated. So we will just make use of the columns that are actually necessary for us. For example, we will be using the wellbore ID. We can use the zone ID. We can use the X and Y coordinate. Okay. And we can use the total depth, and we can, of course, use the porosity. Now, what Power BI does not offer is actually the ability to plot contour maps, or let's say field contour maps. Contour maps is just a way to actually to create X and Y and Z plots in 2 dimension. This is very beneficial for oil and gas engineers who actually usually want to know the distribution of a specific variable over X and Y space. So let me just show you what a contour map is. So a contour map has a very wide use in lots of industries. So basically, this is a contour map, and usually in oil and gas industry, especially upstream, we try to color this map because it will just give you a better representation of what you have in place. So this is not possible in Power BI, but if you integrate Power BI with Python, which is not many people are doing, unfortunately, you can get this type of plot. So let me just show you how you do this. Okay, now since we do not have any visualization support for contour map, what you need to do is you need to drag and drop Python visual to the workspace or to the canvas. Just make it as any size you want. Okay, so I'll just make it a vertical rectangle. And once you do that, start to add whatever variables that you want to work with. Now, for example, I want to work with the variable alias, which is the name of the well. Plus, I want to work with the X coordinate, the Y coordinates, and plus I want to work as well with porosity. This is a porosity distribution alongside the X and Y coordinate. Okay, and just make sure that all the data are imported. Do not summarize or average out everything because we want specific data for everything. Plus, you can add, of course, the total depth. You can add as many data as you want. Now, once you do that, it's now time to actually to write the code that will generate the visual for you. If you just click on it, you will see there is a Python script editor will be activated on the bottom. Just press on this arrow. Now you can write the code in here. Some of the participants have already participated in 2 Python training, so this is very familiar to them. If you do not know what is happening, I will just explain line by line as I go through it. So first of all, you have to actually initialize the plotting library that's being used in the background, which is matplotlib. So matplotlib.pyplot, and that's it. Line number 8 actually initializes this. Okay, so let me just zoom this in a little bit. Okay, now in line 8, we have initiated the plotting library. The next step is actually to start plotting the contour map. Believe me or not, it's easy as these two steps. So PLT dot, we have multiple plotting functionalities in matplotlib. So the plotting functionality I'm looking for is actually try contour F. Try contour F actually represents a triangular contour plotting map with fill capabilities. Okay, so you open and close parentheses because you will add variables to it. Now, the tri-contour map actually will take 3 variables. So X, Y, and Z. Okay, so we can, of course, define those variables prior, or we can just write it in the parentheses. So if we type X equals to, now the data will be saved in the dataset variable. So dataset dot X, the X is going to be the X coordinate that we have. So X coordinate. And of course, the Y is going to be dataset dot Y coordinate. And for the Z, depends on what you're trying to do. Either you can plot the porosity to generate a porosity map, or you can just use the total depth to plot out the depth that corresponds to each specific formation in that at that specific well location. So first, let's start with the total depth. So dataset dot total depth. Now, since we have defined those 3 variables, now it's time to actually to run our code. So X and Y and Z are all defined. So we have X and Y, Z in place, okay, without specifying any more options. Let's just do this plt.show. This will actually show up the plot for us. Now, once you do that, you make sure to click on this run button. And as you can see, it's already refreshing. It will take a few seconds. Of course, if you have some form of error that's happening, you will get it in a message. And the error we're having is actually the name of the library is not correct. So it's matplotlib. We are just missing an O. So let's just run this again. There we go. In a matter of seconds, we have a contour map that was not even possible in Power BI, but luckily now we have it. You can go ahead and do many customization to this plot. For example, usually the customization that we do is actually the contour that should have like a very pronounced or like a very visible edges to them between those different gradients of values. Now, in order to do that, what you need to do is you need to plot another layer on top of the base map. So let's go ahead and do this. So plt dot try contour, this time without the F. This will actually only plot lines for us. So X, Y, and Z. Plus, I am doing something. Let's just make the colors of the edges just different so we can see them better. So rainbow. You can basically select from many color schemes that Matplotlib or let's say Python is offering. Okay, and of course, I would like to control the line width. Okay. So this should equal to 1. Okay, now let's go ahead and run this. Now you can see my contour map is a little bit more better than before. The only thing left is actually to locate the wells on the map, because there is no good map without the locations of the wells. Now, how would you do this is just plotting another layer on the top of those layers that we had before. Now, how do you approach and plot the wells? Basically, there are multiple ways we can do this. And I am showing you the simplest way to do. So type PLT and then scatter. It's just a regular scatter plot. And then you specify just 2 things, X and Y. And of course, you can specify many more attributes. It's called attributes. And so, for example, let's just specify an attribute for the size, which is the size of the scatter, or let's say the size of the well on that particular map. So it's going to be 50 pixels. Okay. And the next thing that we can specify is actually the shape, or let's say the type of the scatter, or the type of the marker that we have. You can select from many available types. So let me just show you where you get all those information. If you type markers in Matplotlib like this, actually it will guide you to a specific page that shows you which particular marker that you can use to generate like specific shape. Okay, and let's just go ahead and use this upper triangle one. Okay, now let's just add this upper triangle like this, and let's just click on run. There we go. Now the wells are located on the map, but it's not very pleasant because the colors of the wells are very close to the colors of the map. So what we need to do is we need to just go ahead and specify a color for our points as well. So let's just make everything black for now. Of course, you can go ahead and divide this, or let's say colorize this based on the type of the well, or let's say based on the condition of the well. And of course, you can have multiple shapes, or let's say multiple markers at the same plot. So basically, this is how you create a plot that does not exist in Power BI. If you have something, or if you have any question related to this topic, please type in the chat box. I will try to answer it afterwards the session. Now, this is the related thing that the Python visualization. Now, let's go ahead and move to the next topic, which is actually using Power BI for maintenance and let's say well and facility monitoring issues. Okay, so it's not always possible just to create like plots for Power BI to monitor specific tasks that are related to inspections. And sometimes the inspections, usually they do not have any plots in place, and they usually work with codes and dates and like what inspection has been done to that specific well and things that are similar to this. Okay, so let me just show you the elements that we are going to create. So this is basically on the left-hand side, we need to create this map. Okay. Once this map is created, we need to populate the locations of the wells, and of course the codes, or let's say the colors for the wells, depends on what you're trying to do. For example, you can use them for the inspection code, or you can just use them for the names of the wells. So both are possible. And second thing that we have is a table that contains all the available codes, or let's say all the available problems that has been solved for that particular well. And this is just a list of, or let's say all the different problems, or let's say different actions that has been taken during the inspection or afterwards the inspection. Plus we have like a specific details related to that well or facility inspection and at which date that inspection has taken place. So let me just show you the basic behavior of this dashboard. If you click on any of those wells, that specific well, whenever it's selected, actually it shows you like what types of the inspections that been happening to that well. For example, we have the NF inspection code. You can just scroll above and see that it says that field inspection well not found, meaning that they were looking for this well for inspection, but the well was not there due to some misinformation or something like this. If you go ahead and just zoom on the chart a little bit, or let's say zoom on the map a little bit, just select another well, you can see we have two codes that are related to that specific well. And if you select any of those codes that we have, for example, let's go ahead and select the casing string witnessed, the CS code. If you click on the CS code, it will only show you the wells that correspond to that specific problem or to that specific inspection that happened at any given time. Plus, if you hold control on your keyboard and click on the CT, which is completion testing, you can also just view those two types of categories, of course. And you can just go ahead and further select whichever well that you want. Plus, you can view like the nodes that are related to that specific well. Now, let's go ahead and try to replicate this. So I will open up a new page. And in this new page, I will add, the first thing I will add is I will add the map, which is a satellite map. Just resize it to some size that you like. Okay, so let's just size it to the full screen width, or sorry, full screen height. And regarding this map takes actually multiple inputs. So the important inputs that we will provide is actually the latitude, the longitude, and of course you can provide as well the colors for which is coming from the legend. Now, where do you get those? Those things you can get it from a table that is specifically holding all the information regarding the well. So let's go ahead and add those. So in the longitude, we will be adding the wellhead longitude. So this is the location of the wellhead. So at this point, we do not care about the location of the bottom of the hole, because sometimes you'll have directional or slanted wells where the location of the wellhead actually does not match the location of the bottom hole. So we are just only caring about the location of the wellhead. And let's just go ahead and drag and drop the wellhead latitude as well. Once you drop those both things, that now you can see you have many numbers of wells has been scattered around the United States area. Basically, this database is coming from Ohio State, where different inspections has been capturing for has been captured for different wells in that state. Okay, now you can see the type of the map is actually, it's not satellite, is just basic road map. What you can do is you can click on the map itself and go to format. And from format, of course, you can change the type of the map you want. If you click on style and you can see it's just a road map, you can, of course, go ahead and switch it to aerial. Aerial is just same as satellite. Different names for the same thing. Now just switch to aerial and wait for everything to load. There we go. In order to interact with this plot, what you need to do is you need to use your mouse clicks, plus you can use your mouse scroll in order to zoom in and zoom out like this. Okay, and let's just go ahead and do another thing. In here, that's been happening to that specific well. And if we go back to an inspection dashboard, if we click on it, you can see those inspections actually, they are coming from the type inspection, which is in terms coming from the table of the inspections. Okay, so let's go ahead and do this. I will just show you in a minute what does that mean. So if we open up a table inspections, so this is the table that contains all the inspections that we have. We have a specific field that's called type inspection. This is field that holds the different information about the inspection codes that has been existing for each specific well. Okay. And you can see my wells, or let's say the inspected points on this map, actually, they are a little bit on the larger side. Of course, you can go ahead and make this smaller by adjusting the format of this plot. Okay, so let's just go ahead and do that. So if we go to format and we go to bubbles, you can see the size of the bubbles. Just make sure that you make this size a little bit smaller, just adjust it until you reach the result that you desire. And this just looks good. Okay, now let's just move to the next step, which is changing the header of this plot, or let's say changing the header of the map. If you go to format and go to general and then title, just delete the previous title and just call this satellite map view. Okay, and you can, of course, change the different aspects of the title as well. You can just make it bold. You can just provide a background for it. For example, let's make this the background this color. And of course, you can change the font color itself or the text color. Let's just make it white. Okay, now, sometimes the user wants just to see what are the types of the error codes, or let's say what are the types of the inspection codes that the specific database has. Now, in order to find this, you need to know where the data is coming from. So basically, it's coming from the codes table. So each specific table of this own actually has like different information from the other tables. And the good thing, actually, you can link each and every table together. I will just show you how you do this. Okay, now let's just drag the code out to the canvas to any empty space. Now, this actually provides you the different codes that we have in the specific database. Plus, just go ahead and drag and drop the definition. So this is the definition of that particular code. So let's just make this smaller and provide a title. Okay, so let's just provide a title. So list of codes. And let's make the background this color and the text as a white. Now, the next step is actually to plot each specific entries for each specific well. For example, if you click on a specific well, it should give you the corresponding codes or the corresponding inspection that has been happened to that specific well. Now, how would you do this? Actually, you will add a table like this. Once you add a table, you can just populate with the inspection data. Now, depending on the inspection data, you can have many inspection data. Okay, so the inspection data I am actually concerned about is the type of the inspection that has been happening to that specific well. So just drag and drop it on that particular table. Plus, you can, of course, use the county, the state, or all the information that you need to view. For now, the information that I am really concerned about are just very few. For example, I am concerned about the comments as well, the comment that the inspector made about that particular asset. Plus, you can go ahead and drag and drop the well API number. So this is the number of the well. Of course, you can just drag and drop whatever field that you feel comfortable with. Now, let's go ahead and test our table. Let's select any of those wells. You can see the wells that I have been selecting is now showing the comments that has been made by the inspector. Of course, the comment is just taking too much space. You can just go ahead and drag it like this. So this will give you a more of a space for you to view. Okay, so let's go ahead and try another well. You can see now these are the comments that we have related to that well. And basically each well can have multiple entries. Okay, so let's go ahead and format this table. So if we go to style, just make it none. Plus the title should be visible as codes for well. And let's just go ahead and click on any of those wells. And you can see now we are started to having like those different things. You can, of course, just select any of those codes. Once that particular code is selected, it should reflect on two places. The first place it will reflect is actually the locations of the wells, or like the existence of the wells on the map, plus the cumulative codes for that particular wells. So this will show all the comments for all the wells. Okay, so if you go ahead and hold control, you can just go ahead and add another type of an inspection. So this will show you two types of wells that are not drilled with code of ND, and well with type of DD. So if you click on any of those, you can just view whatever information that is related to that particular well. And let me just show you one thing. If you go to data view from report to data view and go to table inspection, which is the main table that we are pulling data from, basically this table contains tens and tens of columns, and of course not all the columns like has data, but most do. And if you just look closely on the bottom of the screen, left-hand side, you can see it contains 500,000 rows. And same goes for the table of inspector. So this is the table of failed inspections and the table of details for the failed inspection. Plus, we have two more tables. We have the table locational, which contains all the locations for all the wells. And basically, this database has like a 270,000 wells. And those are just unique wells, non-repeating wells. And basically, it contains all the information about the well, for example, the formation and actually the location, the county, and so on and so forth. And this is all the information that you need regarding the well. You can see we have the county, the state, and the type of the well. We have the status of the well, the spot date, and basically everything else. Now, related to the Power BI, we can do lots and lots of things, but the thing that we usually do whenever we're working with databases is actually how we can make those tables talk to each other. As you can see, those tables contains different information, or let's say different pieces of information that can help them to talk to each other. The key to this question, or the key answer to this question, is actually activating the relationships. So what does a relationship means? A relationship is just basically how different tables are linked together. And if you want to be proficient about relationships, the first step is actually you need to understand how different data, or let's say how different data is being captured and it's being modeled in your company. So this is the first step. If you do not understand how different data are being collected, or how different data are being acquired and are put together, so you cannot actually understand how these different relationships work. Sometimes the software detects the relationships for you, and most of the time it does not. So it's very critical to understand how different relationships actually exist between different tables. Now, how do you benefit from the relationships? Actually, benefiting from the relationships actually enables us to make the list of the code that we have, which is coming from the table codes, which is the first ever table. It makes this table of codes actually talk to the tables of inspection. So let me show you how. If you click on any of those codes, actually it will filter out whatever data coming from the table of the inspection. So basically, this is a very brief overview on how to create inspection and maintenance dashboards in Power BI. Of course, you can go ahead and add Gantt charts, and you can add dates, and you can just add any types of filter you want. To this end, this is the only thing. These are the only things that I have to present. And yeah, if you have any question, we will be having 10 minutes of questions and answers. Please, if you have any, please feel free to post it in the chat box.